Hi, and welcome to another exciting week in Marketing 2700 Design and Product Development. I'm Brad Scheller, and let's talk about design. Take a look at this slide. On the left, you've got a napkin sketch. Somebody sat down with a pen and roughed out an idea for a dashboard. On the right, that's the finished product. AI optimization trends, system efficiency at 98.5%, global node activity, and resource allocation bars. It looks incredible. Here's what I want you to think about. Which one of these is more valuable? Now, most people would say the one on the right. It's polished, it's deployed, it's real. But here's the thing. If that napkin sketch had been tested with actual users before anyone wrote a single line of code, and the team discovered that operators needed 3 pieces of information that aren't even on this dashboard, that napkin would have saved the company months of rework and potentially millions of dollars. That's the return on investment of reality. It's not about how polished something looks. It's about how closely your design aligns with what the user actually needs. And today we're going to talk about why that gap between what you build and what users need is the most expensive problem in product design. And when I say expensive, I'm not being hypothetical. Let me show you what expensive actually looks like. So I just told you bad design is expensive. How expensive? How about $900 million expensive? In August 2020, a team at Citigroup was processing a routine loan payment for Revlon. They were using a financial software system called FlexCube. And the interface, look at it, it's a wall of fields, dozens of inputs crammed everywhere, tiny labels, no visual hierarchy, no confirmation workflow that makes sense. So what happened? An operator accidentally sent $900 million of Citigroup's own money to Revlon creditors. Not Revlon's money, Citi's money. And here's the kicker. A federal judge ruled that the creditors got to keep it because the transfer appeared intentional based on how the system processed them. $900 million. Not because of a software bug, not because of a cyber attack, because of a user interface that made it too easy for a trained professional to make a catastrophic mistake. This is what bad design costs in the real world. Now you might be thinking, okay, that's an extreme example. But the truth is, the relationship between bad design and cost isn't random. It follows a very specific pattern. And pray tell, what could that pattern be? Well, I'm glad you asked. Or I'm glad you thought to ask. Anyway, here's the pattern. It's called the 1-10-100 rule, and once you see it, you'll never forget it. This chart shows the cost of fixing a design error at each stage of development. During the concept phase, catching a problem costs you about $1. Maybe it's a sketch you throw away, a conversation that changes direction. No big deal. Move to the design phase. That same error now costs $10. You've invested time in wireframes, maybe some early code, still manageable. Development phase, $100. Now you're ripping out code, redesigning components, retesting. But post-launch, that same $1 problem is now a $10,000 problem, or as we just saw with Citigroup, a $900 million problem. The curve is exponential. Defect prevention is always cheaper than defect correction. This is chapter 11 of your textbook in one chart. Industrial design isn't about making things pretty. It's about patching problems when they're still cheap to fix. And there's actually a formal theory behind this. It comes from manufacturing and explains exactly why close enough is never actually close enough. It's called the Taguchi Loss Function, and it's one of the most important concepts in robust design theory. Look at this curve. The x-axis is deviation from what the user actually needs, the target. The y-axis is loss, cost, and frustration. That orange area, that's where you're losing money, losing users, losing trust. The key insight here is that quality is not just meeting spec. Traditional thinking says as long as you're within the acceptable range, you're fine. Taguchi said no. Any deviation from the user's ideal target creates loss. The further you deviate, the more it costs. And the relationship is quadratic, not linear. But here's why this matters to you. In a lab, conditions are perfect. Your prototype works exactly as intended. But in the real world, there are noise factors everywhere. User confusion, environmental variation, edge case nobody's anticipated. Robust design theory says design products so it performs well despite not being in the ideal condition. Don't just test for the ideal user and the ideal environment, design for reality. So if the cost of bad design is exponential, and even small deviations from the target create loss, how do you actually prevent these problems? The answer is testing, but not in the way most people think about it. You see, when most people hear testing, they picture the end of a project. The quality assurance team finds bugs before launch, but that's completely wrong. Look at this diagram. Discovery, research, synthesis, ideation, prototyping, testing, iteration, handoff. See how the prototyping, testing, iteration loop has arrows going in both directions? And see that big arc going all the way back from the late stages to discovery? Testing is not a gatekeeper at the end. It's a compass at every step. You test your assumptions during research. You test your concepts during ideation. You test your prototypes during development. Each test is a chance to course correct before the cost of change goes up by another order of magnitude. Remember the 1, 10, 100 rule we just looked at? This is how you stay on the left side of that curve. But here's the trick. When you test, you have to know what to look for. And what users say versus what they actually do are different things. Now, I'd like to say something that I say in most every presentation. This might be the most important slide in the entire presentation. If you remember one thing today, make it this. Now, if you saw another presentation by me today, you're probably going to be very confused as to what to remember. Sorry, but here goes. Watch the feet, not the mouth. What users say, the tip of the iceberg, is what you get from surveys, focus groups, interviews. I love this design. I would definitely use this. This looks great. But what users actually do, their behavior, that's the massive blue shape under the surface. And it almost always tells a different story, completely different story. They say they're paid for it, but they don't sign up. They say it's intuitive, but they can't find the button. They say they love it, but they never come back. This is why observational research, watching real behavior, is worth 10 times what surveys data is worth. When you're testing, don't ask people what they think. Watch what they do. The gap between stated preference and revealed preference is where most product failures live. Now, there's a specific trap that makes this behavior gap even worse. It's something that fools designers every single day. This is called the Aesthetic-Usability Effect, and it's a cognitive bias that can completely derail your testing. Look at the travel app on the left. Beautiful, stunning photography, clean layout, Bali and Maldives. Who wouldn't want to use this? But here's the problem. Research consistently shows that users perceive attractive designs as more usable than they actually are. Beauty masks broken workflows. If your prototype looks gorgeous, users will forgive navigation issues, overlook confusing flaws, and give you positive feedback even when the underlying experience is flawed. This is a critical risk for your team projects. If you build a high-fidelity prototype too early and show it to people, they'll tell you it's great even if it doesn't work. Form over function is a trap. You have to earn the right to fidelity. And this raises the obvious question. When should your prototype be rough and when should it be polished? The answer depends entirely on what question you're trying to answer. Here's a very practical framework that you'll learn in this course. On the left, a cardboard mock-up, rough, physical, you can hold it. In the middle, a wireframe schematic, structural dimensions, button placement, proportions, and on the right, a high-res render, basically a finished product image. Now look at the labels underneath. Lo-fi is for exploration. It's cheap. Mid-fi is for structural validation. Hi-Fi is for final validation. It's expensive. And here's the rule. Match the fidelity of your prototype to the question you're trying to answer. If you're asking, is this the right concept, use cardboard. If you're asking, can users navigate this, use a wireframe. If you're asking, does this animation feel right, then and only then go hi-fi. The most common mistake I see in student projects and in corporate teams is jumping to high fidelity too early. You'll spend 3 weeks building a beautiful prototype, show it to users, they say it looks great, and you've learned absolutely nothing because the aesthetic usability effect just stole your feedback. There's a wonderful phrase that captures this principle perfectly. Paper has no ego. Look at this whiteboard. Post-its everywhere, scribbled ideas, crossed out concepts, arrows going in every direction. This is what real ideation looks like. It's messy, and that's exactly the point. When you show someone a sketch on paper, they'll tear it apart, and that's what you want. Paper invites perpendicular feedback, structural changes, fundamental redirections. What if we do this completely differently? But when you show someone a polished mock-up, they give you parallel feedback, surface tweaks. Make that button bigger, change this color. They're adjusting the window dressing instead of questioning the architecture. In your team projects, I want you to resist the urge to make things look good too early. Ugly prototypes generate better feedback, period. And we don't have to just take my word for it. There's a brilliant study that proves this point exactly. The Diniger and colleagues ran a study in Ghana testing how stakeholders respond to different prototype formats for medical devices, and the results were striking. On the left, a virtual prototype, CAD models, digital sketches. On the right, tangible prototypes, cardboard mock-ups, 3D prints. The y-axis measures actionable feedback, the kind of design input that actually changes the product for the better. Virtual prototypes generated about 25% actionable feedback. Low quality, low quantity. Tangible prototypes, over 90%. High quantity and high quality. The gap is enormous. And why? Because when you hand somebody a cardboard prototype, they can hold it, they can turn it, they can point to where their hand gets stuck. They're using their domain expertise, in this case, doctors who know exactly how a device needs to work in their clinic, instead of trying to evaluate a design concept they can't physically interact with. The key takeaway here connects directly to Chapter 11 in your textbook on industrial design. If you want actionable data, give users something they can mentally or physically grasp. That's true for physical products and digital products alike. So now you understand the principles. Testing is continuous. Behavior beats opinion. Fidelity must match the question. Lo-fi prototypes get better feedback. Now let's get practical. What methods do you actually want to use? Before I get into that, and having said all that about different types of testing, let me say some kind words about the napkin. Now, I would argue vehemently that it is absolutely indispensable if you're eating a hot dog with too much mustard. I would also state that there's a great deal of value if you are obsessive compulsive and you draw out this much detail on a napkin to identify all the various components of your concept and how they interrelate. This diagram is what I would refer to as an architecture diagram. It lays out the process flow, the information, and the components that are linked to each step. Now, if my eyesight wasn't so bad, I could probably tell you what those little shaded boxes have in them as well. But alas, I'm not that young anymore. But what I will say is details like this, even on the back of a napkin, have been shown to be able to identify 95% of logic errors. And if you remember back to the expensive cost of logic errors in the Citicorp example, or the cost that each stage gets passed on, how much more it costs, this is a valuable tool to identify that early on. In fact, as part of your exercise this week, you'll be laying out an architecture diagram for your application. Now, here's the key. I don't expect you to be perfect, but I do expect that you'll be able to use Claude Code by now and have it do the work for you. And this will introduce you to another step in the new product development process, the architectural diagram. But let's get back to the discussion of what types of tests should you do for different situations. So we know what to look for: behavior over opinion, fidelity matched to the question. But how do you actually choose which testing method to use? This is your decision matrix. I call it the Truth Toolkit. Not that I'm going to be able to trademark it or anything, but there's two axes. The vertical axis is about research involvement. Are you sitting in a room guiding the session, or is it running on autopilot? The horizontal axis is about what kind of answer you need, the why behind behavior, or how many that proves it at scale. Now, the top left, moderated and qualitative, lab testing, deep dive interviews, think aloud protocol. You sit with 5 to 8 participants and watch them struggle in real time. This is where you discover things you never thought to ask about. It's expensive and slow, but nothing else gives you this depth. The top right, moderated and quantitative. This is benchmarking, live usability tests. You're measuring task completion rates, time on tasks, and error rates. You need 15 to 20 participants to get meaningful numbers. This is how you prove to your vice president that the redesign actually makes things better or didn't. The bottom left, unmoderated and qualitative. This is session recordings, diary studies. No researcher in the room. You're watching replays of real users on your live product. The rage clicks, the hesitation, the drop-off points. This runs in the background continuously. It's your always-on feedback loop. The bottom right, unmoderated and quantitative. A/B testing, surveys, 5-second tests. You need 100 plus responses to get statistical significance. This is where you validate at scale. Does this headline convert better than that one? Is the value proposition clear in 5 seconds? Here's the key insight. Most teams live in one quadrant. They find a method they're comfortable with and use it for everything. The best product teams move between all four depending on the question they're trying to answer. Early exploration, top left. Proving return on investment, top right. Monitoring, bottom left. Scaling the decision, bottom right. That's the strategic view. Now let's get to the tactical, specific methods for specific questions. So here's your tactical reference. Each method answers a specific question. Match the method to the question. Card sorting and tree testing. The question, can users find what they need? This is about information architecture. If you're building a website or app and people can't find the right page, the prettiest design in the world won't save you. Tools like Optimal Workshop make this easy. The 5-second test. The question is the value proposition clear immediately? You show someone your homepage or landing screen for 5 seconds, then ask them to describe what they saw. If they can't tell you what your product does, you have a communication problem. Heuristic evaluation. The question, does this break standard design laws? This is an expert review. You and a colleague walk through design, checking it against established usability principles. This is fast, cheap, and catches obvious issues. Session recording and heat maps. The question, where are users clicking or dropping off? Tools like Hotjar show you exactly where attention goes on a live site. This is watching the feet, not the mouth. Behavioral data at scale. And finally, guerrilla testing. The question, is this basic concept sane? Grab 5 people in a coffee shop, show them your concept for 2 minutes, and watch their reactions. No recruitment, no scheduling, just rapid concept validation. Now, all of these methods are only as good as the signal you get from them. And getting clean signal requires careful planning. But you know the methods. Now, here's where you actually do them. This is your cheat sheet. 4 categories, end-to-end platforms. Maze and user testing handle everything from recruiting to reporting. Qualitative tools like Look Back and User Feel are best for live observation and interview depth. IA specialists optimal workshops, and UX metrics, they're your go-to for card sorting and trees testing. And for behavioral analytics, heat map, rage clicks, session recordings, Hotjar, and Crazy Egg. This slide will be in your Canvas materials. Bookmark it. And when your team is deciding which tool to use for your project, start here. So, all right, you've got the methods, you've got the tools, but none of this matters if you recruit the wrong people or ask the wrong questions. There are two things that can ruin an otherwise well-designed test. First, recruiting the wrong people, and second, asking questions the wrong way. Now let's talk about recruiting first. The slide says target behavior, not demographics. This is crucial. You don't want women ages 25 to 35 who live in cities. You want people who have tried to book international travel on their phone in the last 60 days. Behavior-based screening gets you participants who actually represent your users. And there's a warning here I love. Testing with colleagues is an echo chamber, not a test. Your coworkers already know your product. They already understand the jargon. They'll navigate it perfectly and tell you it's great. That data is worse than no data because it gives you false confidence. Second, scripting. The Think Out Loud protocol asks users to verbalize their thoughts while using your product. I'm looking for the settings. I expect it to be on the top right. This icon is confusing. That's gold. But look at the difference between a task and a scenario. Task. Click the blue button. That tells you nothing about usability. You told them exactly what to do. Scenario. Find a way to contact support. Now you're testing whether the design communicates clearly on its own. So getting the right participants and asking the right way, that's critical. But even your question framing can bias the data if you're not careful. Now, this slide comes directly from insights in the Ghana medical device study we looked at earlier. The way you frame a question determines the quality of the answer. The left column is design-centric framing. What would you change? That sounds reasonable, right? But the result is silence or vague praise. Non-designers don't know what to change. That question overwhelms them. It asks them to be the designer, which isn't their job. The right column, patient-centric framing, or in your case, user-centric framing. How would a patient feel using this? Now you're tapping into their domain expertise. Doctors know how patients feel. Parents know how kids react. Accountants know what confuses their clients. The result? Rich, actionable data. The concluding rule at the bottom of this slide is one to memorize. Frame questions within the user's expertise, not the designer's. If you're testing a banking app with bank tellers, don't ask them about button placement. Ask them what frustrates their customers during transactions. You get 10 times better data. All right, so you collected all this feedback. Now what? How do you turn a pile of observations into actual design decisions? This is what's known as a synthesis funnel, and it's how you go from raw observations to prioritized action. There are 3 stages. Stage 1, synthesis. You're aggregating raw video, raw notes, raw observations. Everything goes into the top of the funnel. At this point, don't judge anything, just capture it all. Stage 2, pattern recognition. The rule of thumb here is simple. 3 or more users struggling with the same thing indicates a pattern. 1 user getting confused might be an outlier. 3 users getting confused at the same point means your design has a problem. Stage 3, prioritization using the mouse cow method. Must fix, critical blockers that prevent task completion. Should fix, high friction issues that slow users down. Could fix, visual annoyances that don't affect functionality but reduce polish. And notice the signal to ratio check at the bottom. Did the design survive the variations of real world usage? This ties back to our Taguchi discussion. If your design only works under ideal conditions, you haven't achieved a robust design. Let me give you a practical checklist you can use before every testing session to make sure that you're set up for success. So before you run any test for your team project or in your career, run through these 5 questions. Number 1, Defined goal. Do you know what you're testing? Not, we want feedback. What specific questions are you trying to get answers to? 2, right fidelity. Is the prototype matched to the question? Don't build hi-fi to test a concept level question. 3, unbiased script. Are your tasks scenario-based or are you leading the witness? 4, diverse participants. Are they screened for behavior or just for availability? Remember, colleagues don't count. 5, actionable plan. Is time blocked for iteration after the test? If you don't have time to act on what you learn, don't bother testing. And the quote at the bottom says it all. Testing is not a phase you finish. It's a culture you build. This isn't a one-time activity. The best product teams test continuously at every stage. It's a habit, not a step. Now, before we move on, one more principle that should be on everyone's checklist, but rarely is. These 4 pillars, which spell out POUR, perceivable, operable, understandable, robust. That's the core framework for accessibility. And look at the line at the bottom. Accessibility is a requirement, not a feature. This matters for usability testing because if your product isn't accessible, you're not just excluding users with disabilities, you're creating a worse experience for everyone. Curb cuts were designed for wheelchairs, not parents with strollers and delivery drivers with carts use them every day. Closed captions were designed for deaf users. Millions of people watch video on mute in public. Accessible design is better design. When you test, add one more question to your go, no-go list. Can someone with limited vision, limited mobility, or limited tech navigate this? If you don't test for this, your ship is broken. Now, you now have the complete traditional toolkit, principles, methods, tools, accessibility. Everything we cover applies whether it's 1995 or 2025. But the way you apply it, that's about to change. Now, don't panic just yet, because everything you just learned still applies. The Taguchi Loss Function, the 1-10-100 rule, watch the feet, not the mouth, paper has no ego, match fidelity to the question, all of that still applies. But look at this image, a human hand reaching towards a wireframe with cursor paths and interaction points mapped across the surface. That's the bridge we're about to cross. The fundamentals don't change, but the instruments you use to apply them, they're evolving fast. How fast? Let me show you the shift. So again, how fast? This fast. 2015. The way products got designed and shipped was a waterfall technique. Handoffs, silos, a designer made a mock-up, threw it over the wall to engineering. Engineering built it, threw it to QA. QA found problems, threw it back. Every handoff was a chance for information to get lost and mistakes to compound. Today, continuous orchestration. Design, testing, development, and deployment are happening simultaneously, not sequentially. AI systems are in the loop providing real-time feedback, generating variants, flagging accessibility issues before a human even reviews the work. This isn't a prediction. This is happening now. And the question for you isn't whether this shift is real, it's whether you'll be ready for it. Now, waterfall to orchestration, that's the macro picture. But how companies respond to that shift, that's where the real lessons lie. I think you remember Kodak and Microsoft, 2 case studies we've already looked at in this course. And on the left, Kodak, they invented the digital camera. In 1975, a Kodak engineer named Steve Sasson built the first one. And what did Kodak do? They buried it. They had the technology, they had the insight, but they couldn't bring themselves to disrupt their own film business. Invented, then buried. On the right, Satya Nadella and Microsoft. When Nadella took over, Microsoft was a know-it-all culture. He transferred it into a learn-it-all culture. They embraced cloud computing even though it threatened their Windows licensing model. They embraced AI even though it meant rethinking their entire product suite. Here's the parallel to your career. The AI tools we're going to discuss next are going to fundamentally change how product design works. You can be Kodak, see the change coming and refuse to adapt because it threatens what you know. Or you can be Nadella, embrace the disruption and ride it. Beat your competition. So, what does that adaptation actually look like for designers and product teams? Now, this timeline shows 3 eras of design work, and we're actually living through the transition between the second and third right now. In era 1, you had what you could call pixel pushing, 2000 to 2022. Manual control, you open Photoshop or Figma, you move elements around with your mouse. Every pixel is a conscious decision. This is how most of you learn to design. It's craft, it's skill, and it's incredibly time consuming. Era 2, prompting, 2023 to 2024. The era we're mostly in for right now. You type make it pop into an AI tool and it generates something. Natural language in, visual output out. It's faster, but it's also very imprecise. The output quality depends entirely on your ability to articulate what you want. Era 3, intent-based orchestration, 2025 and beyond. This is where it gets interesting. The designer doesn't push pixels or write prompts for individual screens. The designer defines intent, business goals, user needs, brand constraints, and an AI system orchestrates the execution across the entire product. Strategic oversight, automatic deployment, holistic system design. Your textbook's chapter 11 talks about how industrial designers have always worked alongside engineers. In this era, they'll also work alongside AI systems. The skill isn't execution anymore, it's judgment. So the role is evolving, but it's not abstract. There are specific tools making this real right now. So let's talk about a couple of them. First, we'll start with Figma Make. This takes your design system and generates production-ready components. Then there's Uizard. You sketch to screen, you draw on paper, and it becomes a digital wireframe. There's UX Pilot. Behavior simulation, it runs synthetic user tests before you recruit a single person. And with Galileo, generative AI, UI, you describe what you need and it creates it. Now, I would argue that Claude Code and Gemini are displacing all of them, or soon will, but that's another story for another day. These aren't theoretical, they exist. Some of them have free tiers even, and they're getting better every month. One designer plus AI tools equals 10 designers. That's the multiplier effect. Your output capacity isn't limited by how fast you can push pixels anymore. It's limited by the quality of your judgment and the clarity of your intent. And that connects directly to Chapter 11's discussion of industrial design tools. The textbook talks about sketching, foam models, digital rendering, and 3D printing as the designer's toolkit. We're adding a fifth category, AI-generated exploration at scale. One designer plus AI equals 10 designers, but which AI? Let's look at the platforms that are actually designing and delivering on that promise right now. Right now, there are 2 main heavyweights that dominate the usability testing landscape. On the left, Maze. It's AI first, built for continuous discovery. Their big selling point, rapid, unmoderated testing, deep integration with Figma and Adobe, and AI-generated reports that synthesize your results automatically. If you're on an agile product team that needs to test every sprint, Maze is built for that cadence. On the right, user testing. This is the enterprise standard. Where Maze is about speed, user testing is about depth and scale. They have a massive, diverse participant pool. You can get feedback from almost any demographic within hours. deep moderated capabilities, native Figma testing. If you're running a large budget study where compliance and documentation matter, this is your platform. Here's the practical takeaway. Maze for speed and iteration, user testing for depth and compliance. Many enterprise teams use both. Maze for weekly sprint testing, user testing for quarterly deep dives. You don't have to choose one forever. Those are the platforms that try to do everything. But sometimes you need a specialist. And on this page, there are 4 specialists that basically exist for one thing. So Optimal Workshop, it's the information architect. If your Truth Toolkit matrix says you need card sorting or tree testing, this is where you go. It's a standard for understanding how users organize information in their heads. The next one, Look Back, the Observer. This is best for over-the-shoulder remote mobile testing. You're watching someone use your app on their phone, seeing their face, hearing their narration. It's the closest thing to sitting next to them on the couch. Hotjar, the tracker. Heat maps, rage clicks, session recordings. Remember our watch the feet, not the mouth principle? Hotjar is the tool that makes that literal. You see exactly where people click, scroll, and abandon. And it has a generous free tier. You can start using it this week on any live website. Loop 11, the benchmarker. This tracks metrics like time on task across iterations. When you need to prove that version 2 is measurably better than version 1, this is how you do it. So you've got the heavyweights and the specialists, but all of those tools are getting smarter. Let me show you what AI is doing to the testing process itself. This slide shows 4 ways AI is accelerating usability research. And I want you to notice something. None of these replace the researcher, they simply amplify the researcher. AI moderated interviews. Tools like Maze now use AI to ask follow-up questions in unmoderated sessions. The participants say something interesting, and the AI probes deeper. Can you tell me more about why that confused you? You used to need a trained moderator in the room for that. Now it happens at scale, asynchronously. Synthetic users. Loop 11's AI agents simulate user paths to identify friction without recruiting a single person. They crawl your interface the way a real user would and flag dead ends, confusing labels, and broken flows. Remember, we'll come back to the limitations of this in a moment. Automated synthesis. This might be the biggest time saver. Sprig and user testing can now take hours of sessions recording, all those videos of people struggling with your prototype, and summarize them in instant themes. What used to take a researcher 2 days of analysis now takes about 20 minutes. And look at the flow on the right. Voice input goes in, the AI transformation engine processes it, and structural actionable insights come out of it. That's the shift from watching video to acting on insights. Now, AI isn't just accelerating how we test, it's changing how we build. And that brings us to a concept some of you have already encountered in this course. Now, AI isn't just accelerating how we test, it's changing how we build. Now, let me see, you probably heard this concept about vibe coding. Some of you already experienced this perhaps in your team projects. Vibe coding, the idea is simple. Natural language plus a design system equals production code. So Figma, Anima, UX Pilot, Moonchild AI, these tools take your design intent expressed in plain English and generate working code that follows your design system's rules. So look at the flow here. Someone types in, make it pop. That goes through a design system, the buttons, cards, spacing, colors your brand has standardized, and out comes production code. Real React components, real CSS, not a mock-up, not a wireframe, working software. Now, is the code perfect? No. Does it need a developer to review and refine it? Absolutely. But here's what changed. The first draft used to take a week. Now it takes an hour. And that first draft is good enough to test with real users immediately. That's the connection to everything we've been talking about. Vibe coding collapses the distance between concept and testable prototype. That 1/10, 100 rule still applies, but now you can catch that $1 defect even faster because you can put it in a working version in front of users the same day you conceive it. But vibe coding is just the front end of something bigger. The real shift is happening in how AI tools connect to each other. You've probably heard of vibe coding. It's the front end. But the real shift is happening in how AI tools connect to each other. This is a slightly more technical slide, but I want you to understand the concept because it's going to reshape how product teams work. MCP, or Model Context Protocol, which was created by Anthropic or defined by them, think of it as a universal translator between AI and the tools you already use. Right now, if you want AI to help you with your design, you copy and paste screenshots into a chat window. MCP eliminates that. The AI lives inside your design environment. Look at the connections here. Figma API on the left. The AI can read your design files directly, understand your components, and suggest changes. GitHub repo on the top right. It can see your code base and make sure suggestions are compatible with what's already built. Local environment on the bottom right. It can actually run and test the code on your machine. What does this matter for usability testing? Because the handoff problem, the gap between design and development where information gets lost, starts to disappear. When the AI can see both the design and the code simultaneously, it catches inconsistency that would take a team of quality assurance people days or weeks to find. So you don't need to build MCP servers, but you need to know this exists because the tools that you'll use in your careers are being built on top of it. So we've gone from individual AI tools to connected AI systems. But what happens when those systems start working independently? That's a scary thought, right? But the agentic workforce is what we're talking about. And this is where it gets interesting. Look at this dashboard. 3 AI agents running simultaneously. The accessibility auditor is scanning ARIA labels right now, status running. AB variant generator has already finished. It generated 12 layout variants, and the mobile breakpoint adjuster is queued, waiting for resources. This isn't science fiction. Tools like this are being deployed at companies right now. And notice the framing at the top, from building tools to managing the workforce. That's the shift in the designer's role. You're not just prompting anymore. You're managing a team of agents, AI agents. Think about what this means for usability testing. Remember the go, no-go checklist we covered? Define goals, right fidelity, unbiased scripts, diverse participants, actionable plan. An agentic system can handle the mechanical parts of that checklist, checking accessibility, generating test variants, adjusting for mobile, while you focus on the strategic decisions that require human judgment. That's the evolution from maker to prompter to orchestrator to workforce manager. And at every level, the fundamentals we covered in the first half of this lecture, watch the feet, match fidelity to the question, paper has no ego, those don't change. They become more important, not less, because the stakes at each decision multiply when AI is executing at scale. So AI gives you speed, scale, and automation, but there's something else it can't give you, and this next image captures it perfectly. So as you can see here, while AI can give you speed, scale, and automation, it can't give you a body. Or maybe that's the wrong message here. Let me try again here. So we have rows and rows of identical gray mannequin heads and one real face in the middle. And on the left, synthetic users equals scale. On the right, real users equals soul. And at the bottom, AI identifies 80% of bugs, but 0% of emotion. Synthetic users are AI agents that simulate user behavior. You can run thousands of them through your product overnight. They'll find broken links, confusing navigation, dead ends, and accessibility failures. They're incredibly useful for scanning and for scaling your testing. But they will never tell you how a first-time user feels when they realize your product can't do the one thing they downloaded it for. They won't show you the frustration in someone's face when they can't figure out the checkout flow. They won't capture the moment a user says, I thought this would work like, and reveals a mental model you never considered. I personally wonder if synthetic users will in fact evolve to be able to provide the soul information. Just 2 years ago, who would have thought they could do as much as they do now? In my opinion, it's only an element of how much research has been done to identify the different persona in our society based on a number of factors and gather their likes and dislikes, period. Eventually, it all comes down to data, but that discussion's for another day. The future of product testing is synthetic users for scale, real users for soul. Use AI to find the 80% of issues that are structural, then invest your precious human testing time into the 20% that require empathy, emotion, and nuance. That's how you stay ahead. Which brings us back to where we started. There are 3 principles that you need to remember from this entire presentation. Fail cheap, the 1 to 100, to 1 to 10 to 100 rule. Catch errors when they cost $1, not 10,000. Test early, test rough, test before you invest, test truth, behavior over opinion, watch the feet, not the mouth, the iceberg visual, the Ghana study, frame questions within the user's expertise, synthesize patterns, not anecdotes, and orchestrate. AI over manual. You're not replacing your judgment, you're amplifying it. Synthetic users for the 80%, real users for the soul. One designer plus AI equals 10. Those are the sub roles that you found under each of those. Now, if you only remember these 3 words, you have a framework for every product decision you'll make. I got through that one without laughing too much, but that's the truth. If you remember those 3 words, one philosophy, you'll do very well in your career. And it all comes down to one thing. And that is, you are not the user. So fail cheap, test truth, orchestrate, one philosophy. You are not the user. This is the single most sentence in product design. You are not the user. Your team is not the user. Your manager is not the user. At this point in time, the only way to know if your product works is to put it in front of real people in real context with real tasks and watch what happens. The subtitle says it perfectly. The tools change, the responsibility does not. Whether you're sketching on a napkin or orchestrating AI agents, your job is the same. Understand the user, test your assumptions, and close the gap between what you build and what people need. And that's the return on investment of reality. That's what separates products that succeed from products that cost someone $900 million. And that's what I want you to carry to your team and into your team projects this week. So test early, test often, test with humility, because the most expensive assumption in product design is the one you never question.